By the way, guys, I'd love to welcome, Ms. Tremaine Gregory, and she will be presenting on Canopy Bridge Design, emerging recommendations from a growing body of literature.
Okay, thanks so much, everyone. And I'm going to be repeating some of the things that you've seen today, some of the images you've seen today, and kind of highlight the design details that we're learning about canopy bridges. And I'll say that, as Teixeira said in the first presentation, there have not been that many experiments on what animals are using. Really, Fernanda Abra's experiment with the two bridges right next to each other was really one of the first that's really giving us very controlled information about what animals prefer. But we're kind of pulling some information from what we're seeing, some patterns, and so I will kind of give you fuzzy conclusions about what we're drawing from that. So I have to include my natural canopy bridge camera trap image of Pithecia from Peru, but I'm going to focus mostly on artificial bridges. Okay, we can move to the next slide. So as others have touched on, obviously, arboreal mammals are facing a threat that others are not. I mean, a terrestrial animal can cross if they're willing to cross the new infrastructure, but arboreal mammals, many of them really will not come down to the ground, so they become isolated on either side of roads. Next slide. This is a camera trap image from a pipeline. Oops, backwards one. From a pipeline in Peru, where you can see this capuchin monkey crossing, where there's no traffic, there's no human impact, crossing on its back legs. And in this study, we compared crossing in natural canopy bridges and crossing on the ground by arboreal species. We saw over 3,000 crossings in 13 canopy bridges, and we saw just 16 on the ground by arboreal species. So we can really say that even where there's no traffic, when you have a barrier like linear infrastructure, when you do not have canopy connectivity, arboreal species give up and go back into the forest. So it's really necessary to have canopy bridges. And as Farah said, the solutions can be extremely low cost. We're not talking about millions of dollars, we're talking about thousands or even hundreds of dollars to make a bridge. So next slide. So natural bridges, you can't really see the top there, but natural bridges are really obviously the gold standard that we're looking for. This is where we see in both of these studies, the one that Farah just presented, 25 arboreal species crossing, and there she has 8 crossing in the artificial bridges. This is the study I was just mentioning from Peru. That's me climbing that tree 30 meters up. There we had also 25 species crossing in canopy bridges, the natural bridges. When you have artificial bridges, I don't think I've ever seen more than 9 or so species crossing in artificial bridges. So this is what we're trying to emulate, obviously, but it's not easy to do. So next slide. So sorry, there's some examples of those different species crossing in the natural bridges. Okay, next. So when we do try and emulate the natural substrate, we actually do see a preference by animals. So this study, on the left there from South Africa, they did see a preference for this bamboo substrate versus, it was a little bit of a complex comparison because it was one of those lattice designs that they were comparing with, but still there did seem to be a preference for this natural substrate. And this was like a really brief experiment that I did in Peru where we saw lianas hanging down, also a pipeline being cut. We saw lianas hanging down on one side of the pipeline right away. We decided to try just tying them up on the other side. Again, it was about 25 meters high and 20 meters wide. And within a week, these night monkeys started crossing. This was a 20-meter gap in a forest that had never seen a gap like that before. And they weren't afraid to cross if they could have that natural substrate. Unfortunately, these natural solutions can break. This one broke after about 6 months. They don't hold up as well as things like steel cable. So, we need to find something that works for different species. So next slide. So I just wanted to show here some of the different substrates that people are using to build their artificial bridges out of. So I really love these, the recycled seatbelt solution and the agricultural mesh. These are in areas where people are seeing a lot of theft of the canopy bridges, so they're using solutions, using things people don't want to steal. Who wants an old seatbelt? But monkeys do, and other arboreal species do. Oh, sorry, back. The agricultural mesh is basically rendered useless for theft when it's cut into long strips and then turned into a little tube, like you can see there. This is from a study in Costa Rica where they have over 120 bridges inside of a little beach community, and how the monkeys are using them like crazy. So when you use this agricultural mesh, people are not interested in stealing it. This study up here from Indonesia with the irrigation tubing, they're actually getting a lot of community support by using using the bridges not just for arboreal species crossing, but also to move water for irrigation. So they've had a lot of community support on that project. That's a little bit unusual. Your average canopy bridge does not also transport water, but it's a super cool solution. Then down here, you can see the mesh that different researchers are using. And then finally, the example that Farah just presented, the combination of steel cable encased in rope. So there you have like a little bit more of the natural substrate with the rope, but the steel provides it with long-term stability, like first finding no breakage after 2 years of those bridges being in place. I'm sorry, this sounded so weird. Strange. Okay, next slide. So another thing that we're seeing that's been kind of like a change in the canopy bridge research over the last few years is that people are moving from tying their canopy bridges to trees. These are two examples of where the canopy bridges are actually secured to trees. There's a tree back there on either side of the road to click to the next slide. Now with Farah's project and others, you see concrete posts being used. If you could try playing that video there. So this is over a 4-lane highway. So this is a pretty sturdy structure. And so you see how the monkeys are willing to cross over 4 lanes. But so, you know, your transport engineers might be a little nervous about something so flimsy, let's say, but animals really do use them. And if they can be built with cable, theoretically, they would not break. Okay, next slide. So I did want to present some of the examples of the really sturdy bridges that might make your transportation engineers a little bit more comfortable if they don't like those flexible solutions. And talking to Steve yesterday, it does sound like that's the case in the UK. But there, so these are different designs being used for dormice in different areas, and this one here is in Japan, and the other, like I said, is in the UK. And these are being used by these tiny little dormice with a lot of success. So that's super cool. Okay, next. So as Teixeira said, traditionally a lot of canopy bridge studies have used this lattice design. This is the group that she talked about down in Argentina, where the group of high school students saw the problem of roadkills on the side of the road, and they decided to install a canopy bridge. It's super cool. But historically, people have really used this lattice design because that's what some of the earliest canopy bridge studies used. But I think that may come from our thought process, what we'd like to use. We like ladders. We turn our hands this way when we climb a ladder. But if you think about the way arboreal mammals grasp, as Phil was mentioning, they turn their hands sideways. They walk on branches. So the lattice and ladder designs, we hypothesize, may not be their preference. So can you go to the next slide? So that's when we started to look at some of the single line designs and look at what animals we're using there. And we, especially based on this study in the BR 184, 194, we're seeing a preference for the single line. Click next slide. So this is that same video that's not working. But the study from South Africa, again, they did compare different substrates, but in the bamboo design, the single line design did show significantly more crossings. So if you could play the video down here on the bottom. This Lisa's presentation, you could see this too in that lattice design. You see this kinkajou is actually crossing on one side of that two-dimensional bridge. So they're using that grasping technique that I described. So there may be some benefits to the 2 dimensions that it provides, maybe more stability, but in terms of the way the animals grasp on it, and we're beginning to do some biomechanics research with some researchers in Ohio that are looking at how the animals grasp, how their tails move when they're crossing, to see if they really understand the biomechanics of their use of those structures. Okay, next. So again, just to show you this sort of like biomechanics sketch here, this is the way these animals grasp. So, and this is what we've generally been solving for. But I'd also like to talk a little bit about what we're doing for animals that have different locomotor habits. So, 2 clicks, 1 with it. So these are the different locomotor patterns that primates use, and they reflect what all arboreal mammals use. But a couple of groups that there's been less work done for are the suspensory locomotor species. So that's a lot of we have, orangutans, which are actually called quadrumanous because they use all 4 of their limbs as if they were arms or hands. And then you have the gibbons that also use suspensory locomotion. Actually, the adelines down here in the New World also use suspensory locomotion, but they also have prehensile tails. So as you can see in these presentations, we're trying to look for ways to help them with their prehensile tails. Next. So if you could try playing that video, probably turn sideways when we play it, but I think you can still kind of see what's going on there. So this is actually from the National Zoo in Washington, D.C., really strange sideways. But this is an orangutan. If you've ever been there, the orangutan crosses the O line every day, a couple times a day. You can see they're using those 2 lines and using their quadrumanous crossing habits. There's only one study that's seen orangutans crossing canopy bridges, so that's obviously a species that are a group of species we need to look at more solutions for, but probably, the traditional canopy bridge designs are not what's going to work best. Maybe something more like these 2 lines. Then we have gibbons crossing up here again. This is a very small comparative study that they did show a preference. It's hard to tell here, but in this letter F, you can see there are actually 2 designs that are being used, and they're showing a preference for the single line versus the back one. Can you go back? Versus the lattice. So again, it's possible that 1 or 2 lines next to each other are what these guys would prefer. But we really do need to research this more. Okay, next. Let's see, here I wanted to talk about prehensile tailed animals. So again, when we give them a secondary element to grasp, they really do seem to prefer it. And this is a study from Peru where we are comparing 2 different designs, but they were next to each other. There was no vertical grasping point above. If you could try playing that video. You can see this spider monkey, and this is where we're doing some of the biomechanics research. It's flailing its tail around, trying to find a place to grasp, and sort of ends up grasping the other line here and there. So, sorry, those canopy bridges are really overgrown. Placing a camera trap at 35 meters high in tropical forest is not that easy. Okay, so next. So I really wanted to reiterate what's special about the design that Farah's using in outdoor stuff. So here it has a lot of these different things combined, as she was also mentioning. So place for the prehensile tail, the braided rope with cable inside. This bottom line here, the 2-dimensional line, using that kind of with the mesh, I think is actually more for human happiness than it is for the animals. Because I think when people see, and Farah said in the field, when people see the bridge with the mesh underneath, they have the impression that the animals are safer. It's possible it provides a little bit more of a visual barrier for them, but I really think what they prefer, and obviously what they use, are the single lines, either the top one or the bottom one, but not really the mesh. Species that are willing to lounge in these bridges, like howler monkeys, might like the mesh for that purpose. But in any case, I think it's kind of like a secondary feature. Again, we have the concrete posts, and most importantly, a place for camera trap installation. I forgot to say about that spider monkey video. That is the first record ever of spider monkeys crossing a canopy bridge, and that was after 2 years from installation. So the question about habituation, spider monkeys don't like canopy bridges, but they need them desperately. They don't cross on the ground, they're heavily hunted, and so finding something that works for them is really important, and having the patience to monitor for a really long time is also really important. So you need your canopy, your camera trap there, and you need it there for the long term, because habituation is not going to happen overnight for some species. So, and then I just wanted to end with another cool video from Costa. This is shows you like the various ways that these animals use these bridges, and here they're just lounging in there. So cool to see. And again, they habituated to this bridge, but within just a few days, right? So, so this was a solution they were dying to have. So obviously, if you build it, they will come, but it might take them a while. Okay, and then the last slide, I just wanted to recognize all the women. It's not intentional, but they're all women, but yeah, no, women that we're working on this review paper and building this different guidance, learning from all this research all over the world. So, do you have any? If you have any questions, do we have time for questions? Okay, for me or for Fair, I'm going to take this microphone.